In this video, we learn about infinite limits. So these are limits where the function goes to infinity or to minus infinity. For example, I look at the right-sided limit, x going to a from the right, f of x, and if this becomes arbitrarily large by taking x sufficiently close to a, then we call the limit to be infinity. Now I can go to plus infinity or to minus infinity for large negative numbers, and I can come from the right and from the left to this point. So I have basically four definitions. So similar, we can have a left-sided limit going to infinity, we can have a right-sided limit going to minus infinity, or a left-sided limit going to minus infinity. So all these cases are called infinite limits, and I will give you a few examples in a second. In all these cases, we still say that the limit does not exist. Although we have this wonderful symbol of infinity, we still say the limit does not exist. Here's one example, limit x to 0 of 1 divided by x squared. And here on the right, I show you the function, how it looks like. And there you can see if you approach 0 from the left or from the right, the function becomes unbounded. The function grows and grows and becomes infinity. Right? So we can already, from the graph, we can say this limit actually equals infinity. But I also like to introduce a new notation, which is called the epsilon notation. Epsilon is used to indicate very, very small numbers. So as x goes to 0 in this function 1 divided by x squared, then x squared will be a very, very small number. So we write something like 1 divided by epsilon to understand what's going on. And now as epsilon goes to 0, 1 over a very small number is very, very big. So as epsilon goes to 0, this becomes large and larger until it goes to infinity. So in our head, basically, we write 1 over epsilon. Let's look at another example. Here further down we have limit as x goes to 3 from the right of the function 2x divided by x minus 3. And then here on the bottom we have the limit from the left of 2x divided by x minus 3. You see the function here on the right, and the value of 3 is about here. Okay, and then you see that coming from the right the function goes to plus infinity, coming from the left it goes to minus infinity. So let's do this using our epsilon notation. In the first case, as we come from the right, as x approaches 3 from the right, the factor 2x becomes 2 times 3, which is just 6. The denominator is the interesting part, because as x goes to 3, x minus 3 goes to 0. But now we need to know the sign of this one. Is this positive or negative? As x approaches 3 from the right, it is bigger than 3. So x minus 3 is always positive. So here we write 6 divided by epsilon, and then as epsilon becomes small, this goes in fact to infinity. It is different in the other limit, that's why I do it separately. So here we have another 6, but then the denominator, now x is a little bit less than 3, meaning x minus 3 is actually negative. So here we get a minus epsilon, indicating that the whole limit actually goes to minus infinity. And this is in fact what we see here in the graph. This goes to minus infinity. Up here on the right it goes to plus infinity. We call the line axis A a vertical asymptote if as x approaches A from the left or from the right, the function goes to plus or to minus infinity. So you see these are again four cases, right? You can come from the left and the right. You can go to minus infinity or plus infinity. In either of those cases, we call it a vertical asymptote. Let's look at the previous example right here. So the vertical asymptote is right this line here, where x is equal to 3, right? On the left, I go to minus infinity, and on the right, I go to plus infinity. So that's the vertical asymptote. Here's another example which is a little bit more tricky. So I look at the tan function, which is plotted here in blue, and then at the limit as x goes to pi over 2 from the right. So let's see in the graph where this happens. So this happens right here, okay? So here is pi over 2 and I come from the right. And then I look at the function and the function goes to minus infinity. So I can write already this equals minus infinity from the graph. But we can also do this mathematically. So let me do this down here. So the limit as x goes to pi over 2 from the right of tan x is of course the limit of sine x divided by cosine x. So what happens with sine and cosine as we approach pi over 2? The way I do this is I plot these two functions. So the sine function is this, and here is pi, and here is 2 pi. So at pi over 2, the sine converges to 1. So I use my epsilon notation. So the sine gives me something like a 1, and the cosine it starts at 1 and then goes down and up and down and up. And so here is 2 pi, and here is pi. Now I'm at pi over 2 from the right, so I'm a little bit right of pi over 2, so the cosine is negative and close to 0. So this is kind of a minus epsilon case. So from this it follows that the limit is minus infinity. This confirms what we have seen earlier anyways. So let me summarize. So infinite limits we denote by plus or minus infinity, and it can happen from the right or from the left, and they can even be different, the right and the left-sided limits. And whenever they're plus or minus infinity, we call the value x is a, we call this a vertical asymptote. Oh, Tolo. Hey Tolo, what's up? You found a vertical asymptote? Yippee!